Alright, so hopefully this works. We're going to do this example problem over here, and I'm going to pull out the most important pieces when we're looking at infinite x, or really, really large x. The 2x cubed, that's the leading term in the numerator, is the one that's going to be important, and then the x cubed is the leading term in the denominator. This plus x minus 1 and this plus 1 over here, that really doesn't matter in the grand scheme of things when you let x go to infinity. Let's see, that reduces to just straight up 2, which basically tells us that the exponent, or that the horizontal asymptote, as we let x get further and further out, it's going to approach just the straight up number 2. So your asymptote is going to look something like this. Now, is it going to be coming, alright, so here's the big question, is it going to be coming like this, or is it going to be coming like this, or like this, or even like this? There's 4 different possibilities. And my answer to that is, well, there's a way to find out, but to be honest with you, what I would do is I would just, I think the best way to do this I would just say that it's going to approach 2. And I think that what I'm going to do is I'm going to give you full credit for choosing any of these answers, as long as you say that it's approaching some horizontal asymptote above 0. The reason for that is because the best way to figure this out is actually to plug in numbers and see where you're at. Like if we plugged in -1 into this equation over here, we can even plug it into there. Let's see, that would be 2 times -1 over -1. So that would be 2. Huh. Yeah. That makes sense. That makes perfect sense. So at -1, it's equal to 2. Oh, I see. You can't plug it straight into there. You got to plug it into here. So if we plug in -1 into there, that would be 2 times -1, so it's -2, minus 1 over -1 plus 1. Uh-oh. That's a problem. There is actually a vertical asymptote at -1. So I just so happen to choose a point that is a vertical asymptote. So I can't plug in -1. All right, let's try -2. Let's see what happens. So that would be 2 times -8. That would be -16. Minus 2 minus 1 over -8 plus 1. And all I really want to know is this thing positive or negative, or what does this number look like? This is -19 over -6. That's going to be positive 19 over 6. 19 over 6 is, let's see, 6, 12, 18, so that's 3 and 1, 6. So it's like 3 point, let's see, if you put that in your calculator, you'll probably get 3 point, what is 1/6 equivalent to in a fraction? 3.15, I think. Anyway, you'll get some number that's about 3, right? So what my point is that it comes from up here. At -2, this thing is going to be up here. So I'm guessing that the graph is going to look something like this. And what I did was I plugged in points to kind of figure out exactly where that thing is. And then over here, I want to test on this side of the vertical asymptote. So why don't we just plug in 0? 0 seems to be the easiest. That would be, I plug in 0 in for x over here, I would have 0 plus 0 minus 1 over 0 plus 1, so that would be -1. So it looks to me that at 0, it comes down to -1. So my graph kind of comes down from here. So I would say that maybe instead of even what the book says the correct answer is, the correct answer is actually this. I'll tell you what, why don't we go down to Desmos and see what we can find out. 2x cubed plus x minus 1, x cubed plus 1. Alright, let's try that. Desmos graphic calculator. Desmos. Alright, let's see. Fraction 2x cubed plus x minus 1 over x cubed plus 1. Was it plus 1 or minus 1? I can't remember. X cubed plus 1. Yep. Alright, so check this out. Actually, what I graphed is pretty straight up accurate. So, as you come in from infinity and go down to the left side, you're going this way. And then there's this weird bumpy looking thing, and I didn't account for that, but I did account for the horizontal asymptote and the vertical asymptote. Now the horizontal asymptote is not necessarily a line that it never touches. The horizontal asymptote is always a line that it approaches and gets close to. The vertical asymptote will be a line that the graph will never touch. So that's the difference between the horizontal and the vertical asymptotes.